Okay, so we're talking about analytic vector addition, and the last part is this tangent function. And I want to show you a problem with respect to the tangent function. And we'll record this so that if you're not hearing me, then you can listen to this later. Okay, but this is a representation of our problem here, and I just rounded the numbers to whole numbers. Okay, and we know that this right here is our origin, and so this vector, this resultant vector, is in the first quadrant. And we know that if we set up a table of the quadrants, this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Right? Now, all x's and all y's are positive in the first quadrant. And all x's are negative and all y's are positive in the second quadrant. Both x and y's are negative in the third quadrant. And in the fourth quadrant, we have positive x's and we have negative y's. Okay? I want you to tell me what is the sign of this ratio for vectors that end up in the third quadrant. What is the sign of this ratio for vectors that are in the third quadrant? It's positive, because all x's and all y's are negative in the third quadrant. So negative divided by negative is positive. Your calculator cannot tell the difference between a resultant vector that is in the third quadrant and a resultant vector that is in the first quadrant. And so it automatically gives you a value for the angle in the first quadrant.
So then how do you know which quadrant?
So the question is, how do you know whether the angle is correct or whether it's off by 180 degrees? The way you know is you look at your values that you plug into x and y. If they're both negative, then you have to add 180 to the value of the angle to get it into the correct quadrant. Okay? And so any vectors that are supposed to be in the third quadrant will be reported by your calculator in the first quadrant, and you'll have to add 180 to those values.
Is that only for this one? Or the third quadrant?
Oh, we're gonna get the other ones. Okay, first quadrant is good to go. It's correct. If it's supposed to be in the first quadrant, it'll be the right answer. Okay, what about the second quadrant? All values of this ratio in the second quadrant are going to be what sign? They're going to be negative, because y divided by x in the second quadrant is going to be positive divided by negative. So you're going to get a negative ratio, and you're going to be taking the arctan of a negative ratio. And it's going to give you a value that is in the fourth quadrant. What about the fourth quadrant? What are the signs of this ratio for all values in the fourth quadrant?
Negative.
They're negative, because you have negative y divided by positive x. Remember, they're different signs, so negative y divided by positive x is negative. It's a negative ratio, and so you're taking the arctan of a negative ratio, and it's going to give you a value in the fourth quadrant. Okay? Okay, so here's the other problem. Values that your calculator gives you in the fourth quadrant are going to be negative angle values. So let's write that down. These are going to be negative theta values. For instance, it might say negative 15 degrees. You start from the positive x-axis, just like we always measure, but instead of measuring counterclockwise, which is in the positive direction, you go clockwise, which is in the negative direction. So if they give you negative 15 degrees, what they're really telling you is 345 positive degrees. But the calculator doesn't tell you that. It tells it to you in the negative. That's correct. Negative 15 is positive 345, right? You're just going around the circle in the opposite direction. But we like to have angles that are positive. And so if you want to leave it as a negative, that's fine. Your answer is right. But if you would like it to be positive, then you're going to have to add 360 degrees to it to make it positive. You can add 360 or leave it alone. Okay? Now, getting back to the second quadrant. Any vector that belongs in the second quadrant, your tangent function is going to tell you that it's in the fourth quadrant, because it can't tell the difference between vectors in the second and fourth quadrants. So it defaults to the fourth quadrant. You have to check your x and y value. If your x and y value are negative and positive, then you know it belongs in the second quadrant. So how do you turn that negative angle that it will give you in the fourth quadrant into a positive one that's in the second quadrant? You add 180 degrees. So let's say that 15 degrees that's negative, that's in the fourth quadrant, let's say that actually belongs in the second quadrant. If you add 180 to it, you get 165, which is in the second quadrant. Okay? Any questions? Yes?
So, you use the negative and positive for the y, and how can you determine if it's in the second and the fourth quadrant?
Okay, so the question was, how do you tell whether a vector is in the second quadrant or the fourth quadrant? You cannot look at this magnitude right here. You can't look at r. You have to look at rx and ry, the components. See, this value is always going to be positive because it's a magnitude. When you square these values, the negative sign is squared out, right? If rx is negative, negative times negative is positive. So this value is always going to be positive. It's just a magnitude. You have to go back to rx and ry and look at their values. This one is positive and positive, so you know it belongs in the first quadrant because all x's and y's in the first quadrant are positive. Well, you just have to know this, which you already know it from math, right? You just have to check the x and y values of your ordered pair. It's not really an ordered pair because it's a vector, but it's similar rules to ordered pairs. Okay? Okay.